we'd like to show you what they look like in practice. Like what do they do? How do they work? What actually goes on in agentic programming? And I believe that Steve has something that he would like to show. So Steve, you've built your own agentic programming harness, as I understand it. So why don't you come up to the green carpets at the top of the room and present what you've done?
Actually, I was going to start off with a terminology overview.
Oh, you're going to start off. Yep. Go ahead, Todd. Yep. So Todd, it's going to be Todd, and then Steve, and then me again.
Okay. Let me here. All right. So, Walter and I ran a similar workshop at AAPT this summer, and one of the things we realized is there's a huge variety of skill levels coming in here, from everyone from I've heard about it but haven't done it, all the way up to, yeah, I'm writing my own tools in the background. So I just wanted to go through a brief primer on the terminology, just so we have a common language and everyone's up to speed. But one of the things I wanted to highlight is what Andy Gavin called the AI rabbit hole of death. Basically, we saw this was true at our PICUP workshop in River Falls. All conversations about computation ultimately turn into a conversation about AI. So this is a perfect example of that. So just to start off with, get this out of the way, AI is a really broad category, but all we're going to focus on is the large language models. So when we say AI, we really mean an LLM. A couple other basic terms, things like chat is basically a way to interact with the text prompt. Hopefully everyone's had some experience with that. Tokens are how the large language models actually think about these things. If you look at the text down here, I typed that sentence into this link down here, and it showed how OpenAI wanted to go ahead and break that up into individual tokens. And so this is what the model is seeing. Now, in a lot of cases, it's actually breaking it up into words, but interestingly, it broke TikTok up. And I'm wondering if it's because I didn't capitalize TikTok. I don't know. But it kind of gives you an idea of what it looks like to the large language model. When we talk about something like the context window, this is basically the sum total of the prompt that is getting fed into the large language model. One thing is that every time you submit something to a large language model, it doesn't just put in the text that you have just typed, it puts in a much larger set of the history of the conversation gets run through, which is part of why these large language models get to be so expensive, is because anytime you have a chat, that text of that chat gets fed in every single step of the way. Markdown, if you're not familiar with it, is just kind of a simple, I've kind of heard it referred to as HTML for dummies. It's a way to have the text displayed in a way that's easily understood, easily read by humans, but gives you a little bit more than just plain text. And then the harness is what we'll be spending a lot of time talking about today, and that's the software you're using for interacting with it. So if you come away from this with no other insight, it's that everything that we're doing is a text prompt, okay? All of the interactions that we're having with these large language models, it's just feeding text into the model, and then it's using its magic to generate the next letter in that prompt or the next token in that prompt. But it's all text behind the scene. The harnesses, all they're doing is taking the text and then maybe calling some tools. So everything is a text prompt. It's just sometimes these different platforms are kind of hiding that behavior behind the scene. Okay, so one of the key insights to making these things useful was the idea of the agentic loop, where you go ahead and you input your prompt. I'm using Claude as the example, but this works with any of those models. The model will evaluate it, and based on that evaluation, it may make some tool calls, and then the results of that, the text output from those tool calls get fed back into Claude along with all of the history in the original prompt. And then this cycle just continues until you repeat, or until you reach a state where Claude is satisfied and wants to halt that loop. This is really what I think has allowed these models to become so incredibly powerful, the idea of this loop. So chat versus harness. Chat is basically a way of interacting with that large language model, but when we're talking about it, a lot of times we're talking about the chat window that shows up either on the website or inside the software that you're running. And then the harness is the software itself. It's surprisingly simple what the harness can do, and Steve is going to highlight that quite a bit. So the more common examples of these harnesses, Claude Code, CoWork is another one, OpenAI has Codex, and they just came out with Work, the very originally named OpenAI Work. But there's a whole slew of other harnesses out there. And like I said, Steve will show what this harness looks like. He's got a GitHub where he's got 250 lines of Python, which basically does the same sort of thing that something like Claude Code is able to do. But again, one of the things I want you to keep in mind is that behind the scene, all that's happening is a chat. And that sometimes that harness will represent the chat, says something about using a specific tool, whether it's reading a file or writing to a file or doing other actions. But in the background, all that's going on back there is chat. So what was I gonna say? Oh, yeah. So the harness is basically the program that's running that agentic loop. A lot of us are using Claude Code or the Claude desktop, but any of these platforms are going to follow exactly the same sort of process, where you go ahead and you collect that context. It's going to involve both your chat plus any calls that you make to files. You can, in a lot of these platforms, you can drag and drop text files into the chat window, and then that text gets added into the prompt. That gets fed into the large language model, which does its little magic thing and gives you an answer. And then based on that answer, the harness may or may not do something. And this cycle then continues until it reaches a stopping state. This is that agentic loop happening over and over again. Just a couple of other tools or terms for rules. These are text files that are always loaded into the prompt. One thing to keep in mind is that rules are more of guidelines. These large language models kind of have a mind of their own in some sense. They like to jump outside their guardrails when they feel it's going to get them to their end goal. So rules are not hard and fast. It's just any sort of text that gets loaded into your chat, and you just don't see that. If you played around with command line at all and you have something like claude.md or agents.md, those are kind of rules-like files. Skills, again, this is just a text file, but it's typically used for tasks that you do over and over again. One of the ways that I've used it is I'm planning to switch to using WebWork, which is an online open source homework platform. And I've been having it write the code for the homework problems. And so since that's a task I've been doing over and over again, I go ahead and I create a text file that lists the steps I want it to follow. But the key thing that distinguishes a skill from an agent is that the skills are something you have to call, okay? You have to explicitly say, hey, use this skill to complete this task. Agents, again, it's just a text file, but the harness treats it a little bit differently. It gives it a little bit more freedom to do that agentic loop. But again, behind the scenes, it's nothing more than a text file that gets read into the context. One example of a agent that I have is a physics education research paper reader. if you go to the Tuesday presentations folder in the Google Drive, I do have the full code for that agent. But this is kind of the beginning parts of that. What I can do is I can feed a PER paper to it. The agent will then go through the paper and look for things like key insights or common misconceptions or teaching strategies that will work. And then I have a master file that collects all of this information together. I have another agent that I can feed it my lecture slides, and it will compare it against the findings of this PER agent to find out areas where I may have missed misconceptions or teaching strategies that I can use to more effectively teach what I'm doing. Again, the full file is in the Tuesday presentations folder. I will state this is part of a stable of agents that I have. They're actually run by a top level agent that I call my lab manager, and then it calls these agents out separately based on what sort of tasks
Who doesn't, Chubbit?
Complete. So how do you get started using these things? Just ask an LLM to create this for you. That's how I started off. I said, I want an agent that will do X, Y, or Z, and then it helped me walk through the different steps of putting this together. Some of the ways that I've been using this is I've been trying to get it to do some tutoring for me. I know students use these things for doing their homework problems, but it just spits out the answer. And so what I've done is craft a tutor that I think doesn't give them the answers right away and then walks them through the steps. You can see that over here. That's the Stout Statics study bot. I've only deployed it for the final exam for my spring semester, so I haven't, I'm still tweaking it quite a bit. Let's see here. Oh yeah, and I've used it primarily for development related to the trinket.gopickup.org, as well as to doing a lot of the system administration on there. I've never done system administration before. And so I've been using Claude to help me figure out what to do and what to look for, things like that. As Larry pointed out, you don't need to know anything about the language. I've also done some programming. I created what I call my carpenter's helper. If you've ever done carpentry, everything's done in 1/8 or 16ths of an inch, and doing the math gets to be laborious. And so I created an iPhone app that handles these fractions for me, so that when I'm doing my carpentry projects, this can really work and help me out quite a bit. One last thing, I put in some other terms here. I'm not going to go through all of these, but there's just some of the terms that I came across in my as I've been learning how to go about understanding these things. So I'm going to turn it over to Steve now. If I can find where the window is. There we go.
Walk up here and let me share my screen. Actually, I might just share the whole screen. Is that dumb? Okay. And okay, first let me start with the code. So there's the URL is here. I also created a document in the folder that's linked in the links that are available through the bottom or lower right-hand corner there with these links. So anyway, this is the Python script that Todd mentioned, and it's just Python, and it's, I don't know, how many lines is it these days? It's less than 500 lines, but it's pretty easy to understand. The main prompt is here. It says, you're a coding assistant whose goal it is to help solve coding tasks. You have access to a series of tools that you can execute. And then it says, it's not even spelled right. It should be, here are the tools you can execute. And then it has a placeholder there for the tools. And then it says, when you want to use a tool, reply with exactly one line in this format. its tool, and then the tool name and the arguments, and nothing else. So what I want to point out here is that the prompt that's being given to the LLM tells it the syntax that it needs to use when it feels that it ought to use a tool. It gets to decide when it's appropriate to use a tool. It gets to decide what tool to use, and it can respond to this program. This program is called a harness. It's basically just a program that's designed to interact with the user and interact with the LLM and try to get stuff done. And so it's telling the LLM, when you want to use a tool, just let me know. Just send me a message that tells me that what tool you want to use, what arguments you want to call, and I'll take care of it for you. And that's basically it. Then the harness, when it gets the result of the tool call, it passes it back to the LLM in the next prompt. And I want to point out also that the tools are literally just Python functions. So here's the read file tool. It takes a name, the path to a file. It goes out and opens the file, it reads it, and it returns the results. There's the list files tool that lists all the files in a particular directory. There's the edit file tool that takes the path to a file, the old string and the new string, and it just replaces the old string and the new string. And that's it. That's all the tools that this is a pretty dumb agent. It only has 3 tools. Claude Code has lots more tools, but they work basically exactly the same way. And finally, there's a, let's see, there's a function here called run turn that does 1 turn of the harness's agentic loop. That's the agentic loop that Todd mentioned. It's basically implemented here. It calls the LLM, it checks to see if the LLM is asking to invoke a tool. If it does, it calls the tool, it takes the result of the tool and passes it back to the LLM, and so on until it's done. So the point is, this is all visible to you. You can go look at it and see how it works. At the Slice conference, I just ran this directly in the debugger and showed folks how it worked. But I realized that wasn't exactly ideal because the debugger is a little bit tedious. And so in the meantime, I asked Claude to cook up a web application that runs the harness in basically in a web browser, but shows you all the bits. So I'm going to ask, and this is actually running on a local LLM running on my computer. But let me go ahead and just ask it a question. I'll say, please list the files in this directory. So it's going to call the list files tool. I presume that would be the obvious thing to do. Then check in simple, let's see, what was the name of the simple underscore agent .py and explain what the, what was it called? Run turn, what the run turn function does. So I'll just say go, and it's going to notice the LLM got the question. It responded with a tool call. Then the tool call listed the files. It returned the results to the LLM. It then responded, and it came back with, let's see. Oh, it came back with a thought. Okay. Please don't share your thoughts. Just answer the question. Here's the thing about LLMs. They're not deterministic. You can ask them the same question 2 different times, and you get different answers. Well, it looks like it's gone off. Daggone it. Okay, let me start this over. Okay. Now I've lost, hang on a second. Okay, well, daggone. This worked fine when I tested it earlier. You've probably heard that before. Let me try and refresh. How many files are in this directory? Let's just try that. Okay, so what is the, let's see, function of the run turn method or function in simple agent.py question. No, it's done. So somehow it's sending me thoughts now, and I think my code doesn't handle thoughts. So I think that's breaking it, but you get the idea. Let's just look at this request number 3, and that was the other point I wanted to make. So here I asked a question, how many files are in this directory? It responded with a tool call request. Tool call listed the files. It got the result with all the files in the directory. Then notice after it got the result, it called the LLM again with the result. So notice, here's the system prompt. You're a coding assistant. Here's the user prompt. How many files are in this directory? Here's the tool call that it made. And here's the result of the tool call with the answer to the question. And now it's responding again. There are 12 files in this directory. So now when I went to ask the next question, which is what is the function of the run turn function in simple agent, I want to point out that it included everything, the system prompt, all the conversation that had happened up to that point, including the new question. So if you're in a conversation with an agent, when you ask a new question, it's taking all the stuff that's happened